Okay, kids, something a little fun here. What we're going to try and do is we're going to try and derive the formula for an ellipse from its definition. And we've got a couple of little ideas in our toolkit here that we're going to use to do that. So we're going to use the Pythagorean theorem to deal with distance, the Pythagorean relation for an ellipse that we talked about this morning, and the binomial square rule there. So let's draw a picture first. So here's my ellipse. Okay, and draw our axis through here. Okay, and what a formula for an ellipse says is that the distance from each focus to a certain point on the ellipse are all going to equal 2a. So here's my first focus, and the distance to that focus we're going to call minus c. And here's my second focus. We'll call the distance to that one c. And our point up here is xy. Okay? So what we'd like to do is we'd like to find the distance from our first focus to our point. So we're going to use a Pythagorean theorem there. And if I draw a vertical line down to our point to the x-axis, I'm going to make two right triangles, one here and one here. And the distance from here to here we know is x, and the distance from here to here we know is y. Okay, so the distance from F1 to P, our first focus to our point, is going to be from here to here squared plus here to here squared is going to give me that distance squared. So let's go ahead and find that distance here. Here, I've got to move this up a bit so we can see what I'm doing here. So to find the distance between our point and our first focus, I'm going to say that that distance squared is equal to x minus c all squared. So that's this distance plus this distance squared plus y squared. Okay? So my distance between my point and my first focus, take the square root of both sides, is going to be the square root of x plus c all squared plus y squared. So now the distance squared between our point and our second focus, okay, is going to be c minus x all squared, this distance here, plus y squared. So that distance, take the square root of both sides, it's going to give me the square root of c minus x all squared plus y squared. Let's go ahead and apply that to our formula. So I'm going to have PF1, or our definition I should say, plus PF2 is equal to 2a. So substituting in square root of x plus c all squared plus y squared plus square root of c minus x squared plus y squared is equal to 2a. Okay, and now the algebra begins. Okay, we're kind of moving away from our picture now, and what we want to try and do is we want to try and simplify this out so that it looks like our formula of an ellipse. So we're stuck here with these looking like ugly root signs, and we want to get to here. That's our goal. Okay, so let's start by getting rid of one of those root signs. So I'm going to leave one on one side, and I'm going to subtract the other one from both sides so I can square both sides and see if we can do any simplifying. Okay, so I know I can get rid of this root sign by squaring both sides. So there we go. So on this side we're going to be left with x plus c all squared plus y squared. And on this side we've got a binomial square, so we've got to be careful. We have to simplify that out properly. So here we go. First term squared is 4a squared minus 2a squared times the root of c minus x squared plus y squared all times 2. So that's going to give me minus 4a square root of c minus x squared plus y squared. Okay, and for our last term is this term squared. So plus, again, c minus x all squared plus y squared. Okay, so let's simplify both of the binomial squares that we have here and see what's the same on both sides. Okay, so here we're going to have x squared plus 2x, or let's call it cx, plus c squared plus y squared. Okay, so that completes this, is equal to 4a squared minus 4a, not much I can do with this yet, c minus x all squared plus y squared. Now let's simplify out this binomial square here, so I'm going to get plus c squared minus 2cx plus x squared plus y squared. Wow, I can hardly fit that on into the line. Okay, but now a couple of nice things happen. I've got x squared is the same on both sides. Okay, so we can get rid of those. Y squared is the same on both sides. We can get rid of those. C squared is also the same on both sides. Okay, so what I want to do now is I want to get rid of my other root sign. So I'm going to isolate it on one side. So I'm going to take it, I'm going to add that root sign, minus 4a, root of c minus x squared plus y squared, to both sides. So sooner or later I'm going to write the root sign long enough. Okay, and on the other side here I'm left with 4a squared. Okay, and here I had minus 2cx, and I've also got plus 2cx on this side, so I'm going to subtract minus 2cx from both sides to get minus 4cx. Okay, and it looks like I can factor out a 4 here, so let's do that. Make life a little simpler. Oops, minus cx that should be. And now I can divide both sides by 4. So we're left with this. Okay, so to get rid of the root sign, now I guess I gotta square both sides again. So let's square this. Now let's square this. And here I'm left with a squared times c minus x squared, all squared, plus y squared is going to be equal to, and here we got another binomial square, so I'm going to get a to the 4th minus 2a squared cx plus c squared x squared. So let's, oh, this is all in one bracket there, so we've got to distribute the a squared out. But first let's deal with this binomial square. So I got a squared times c squared minus 2cx, ooh, I like that, plus x squared plus y squared is equal to, and this is the same on this side, squared. Okay, and now let's distribute this a squared through minus 2a squared cx plus a squared x squared plus y squared, and let's see what we can simplify here. Cx plus c squared x squared. So it looks like 2a squared cx and 2a squared cx are the same on both sides. Oh, you know what? I see I made a mistake here. I need to distribute this a squared into the y squared too. So this should be plus a squared y squared. Okay, so now let's take a look at our formula here again. We want to get to here. All right, so I can see that all my x's and y's are on the same side of this equation, or this one over here. So I'm going to do that same thing, and I'm going to take all of the terms that have x and y over to that side. So we can move this up a bit. Okay, so I got a squared x squared plus a squared y squared, and from the other side here I've got another x, a plus c squared x squared. Okay, which I'm going to change to minus, because I'm going to have to subtract it from both sides to get that. Okay, over here I'm left with a to the 4, and this term I'm going to subtract from both sides because it doesn't have an x or y in it, so I want it over here. So minus a squared c squared. Okay, now both of my x's have, or I've got these two x's in common here. So you know what, let's just let's put those two together. I'm going to put the two x's together just so it makes it a little bit simpler, so we can see this next step clear. And what we want to do here is we want to factor out what we can from these two terms. So each of these has, whoops, an x squared to it. So let's take out x squared, and I'm left with a squared minus c squared. Oh man, I'm making little mistakes here. Okay, and after that is plus a squared y squared. And with this one, it looks like I can take a squared out as common to both terms. So let's factor that out. And it looks like we got something in common in both sides here. I've got a squared minus c squared. But if you can remember from before, I know that my relation for an ellipse, my Pythagorean relation for ellipse, okay, is written like this, but I can also change this around, so I write it like this. B squared is equal to a squared minus c squared. Okay, so b squared is actually, when we're talking about an ellipse, equal to a squared minus c squared. So we're going to incorporate that here. B squared is equal to a squared minus c squared. So I can really write this like this when I substitute. X squared b squared plus a squared y squared is equal to a squared b squared. And now we're almost home. Okay? All I'm left to do now is to get 1 on this side of the equation. So I'm going to divide everything by a squared b squared and looky here. My b squares cancel out, my a squares cancel out, and on this side I'm going to get 1. So my grand finale here is that I end up with x squared over a squared plus y squared over b squared is equal to 1, which is our formula for an ellipse. So watch that a few times, kiddos, and give it a practice and try it on your own. Have fun.